So now the unit circle. The unit circle allows us to find the trigonometric ratio of any angle. How does it do that? Let's consider a point P, and point P lies over here, which lies on a circle, and it can vary. So P can lie on any point. So it can lie here or here or here to change the angle. So if it lied here, the angle will be this, right? But I choose it to be here for this derivation, okay? So x and y, right, are coordinates of P. And because P can vary, P can be any point on the circle, your value of x and y could be positive or negative, right? And then this r, which is here, is the hypotenuse of this right angle that is formed, right? And it is equal to square root of x squared plus y squared. Now, this value of r is always positive, okay? Then using your trigonometric ratios from earlier on, you should get sine theta is a y over r, because sine is opposite over hypotenuse. Then cosine is adjacent over hypotenuse, so it's x over r, and tangent is opposite over adjacent, so it's y over x. So let's take note of these few trigonometric ratios. So because point P can vary to produce the angle that is desired, and x and y as a result can be positive or negative, you will see that in the first quadrant, so this quadrant, the first quadrant here, your x value of the any point, so if that point lies on the first quadrant, which is like anywhere here, then the x coordinate will be positive and the y coordinate will also be positive, right? But if it were in the second quadrant, so this quadrant, if point P light maybe here instead, then it's in the second quadrant, x will be less than 0 and y will be greater than 0. And similarly for quadrants 3 and 4, where in quadrant 3, let's say point P lies here, x will be less than 0 and y will also be less than 0, right? Then in the fourth quadrant, here, x will be greater than 0 and y will be less than 0. And take note, your r is always positive. And because your different trigonometric ratios are a ratio involving y, r, and x, right? Depending on which quadrant your angle is, your ratio would be positive or negative, right? So these three trigonometric ratios would have different signs in different quadrants. Now, let's take a look at the different quadrants and the different signs of the trigo functions in each quadrant. So in the first quadrant, all of them are positive. Right? All of them are positive. Sine, cosine, tangent, all are positive. In the second quadrant, only sine is positive. Cosine and tangent are negative, right? Then the third quadrant, only tangent is positive, okay? And in the fourth quadrant, only cosine is positive. So a way that people remember this is to remember it as ASTC, right? ASTC. So A would mean all. So all are positive in the first quadrant, and S, the second quadrant, would mean only sine is positive because S stands for sine, A stands for all, and the third quadrant, T, means that only tangent is positive, tangent. Then the fourth quadrant, C, meaning that only cosine is positive, right? So instead of memorizing which angles are negative and positive in which quadrant, it is easier to memorize the trigo functions that are positive in each quadrant. So let's look at this question. If we are given that sine theta equals to 2 over 3, how can we find cosine theta and tangent theta without solving for theta? Now take note, here 2 over 3 is greater than 0, so sine theta is greater than 0, right? Which means that theta is actually in the first or second quadrant. Because sine is positive in the first and second quadrant. So we draw a triangle to represent this angle. And let's say it's in the first quadrant. Okay. It should say that theta is actually acute. Theta is acute. Right. If not, we won't know if it's the first or second quadrant. Right. In this case, we assume theta is acute. So this case, we're assuming theta is acute. Because we know that theta can either be the first or second quadrant. So first we assume it's in the first quadrant. Then we draw this triangle. We draw this to show the first quadrant. Then we draw the triangle like this. Right, then this is theta. Then, because sine theta is opposite over hypotenuse, our 2 will be here, 3 will be here in the hypotenuse. Then to get the adjacent side, we use the Pythagoras theorem to get that adjacent side is root 5. Then we find cosine. Cosine is adjacent over hypotenuse, so it's root 5 over 3. Then tangent is opposite over adjacent, so it's root 2 over root 5. Okay? So just now we were assuming that theta is acute in the first quadrant, right? But theta could also be in the second quadrant because we only know that sine theta is positive, which means theta is first or second quadrant. So now we need to consider the case where theta is in the second quadrant. So if theta is in the second quadrant, we will draw the axis like this instead, and our theta will be here, okay? Then this will be our right angle triangle. So again, sine theta is opposite over hypotenuse. So the 2 is here and the 3 is here. Then here is negative root 5. Now take note the adjacent side here is negative root 5. Because the x value here is actually negative root 5. Right, on the Cartesian axis. Because this is in the second quadrant, right? So cosine theta, adjacent over hypotenuse. Adjacent is now negative root 5. Then hypotenuse is 3, so cosine theta is negative root 5 over 3. Then tangent theta is negative 2 over root 5, because tangent is opposite over adjacent, so it's 2 over negative root 5. So take note that in the second quadrant, cosine and tangent are both negative, which is what we learned earlier, right? Because only sine is positive in the second quadrant. So you need to take note that when you're drawing angles in the second quadrant, this length over here, not the length, but the value here, the adjacent, is negative. So remember to put a negative sign. So this is how trigonometric ratios are related, okay? And it looks like it's very complicated, but they are all derived from ASTC and your basic angle, the representation of a angle in terms of its basic angle. And no, you do not need to memorize these, right? Okay.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.